So the three algorithms we looked at in the last video all had nested loops. And the good news here is that these ones won't. So that'll make them a little bit easier. Only one loop will be required, but there's still some tricks. So we're going to try to shift all of the array values one to the left. And in the first one, we're not going to worry about a rollover. So here's what I mean by that if you don't quite understand. So in this array, to shift all the values left, would mean that the array would open with 85, 3, 81, 47, 73, 100. Now, if we were rolling over, you could then take that 56 from the far left index and roll it all the way over to take the 100 place. So in this one, we're not going to do that. And that would mean that in this example, the number 100 would appear twice in the array, in the second to last and in the last index. In the next one, we'll put in the rollover, and we'll actually shift by 2 instead of 1 just to try something different. And we'll go to the right. Okay, so here we're shifting to the left. And so again, we're going to need a loop here. Okay, so if we wrote just our standard loop, so if we started this at index 0 and we walked all the way across the array to num's length -1, which is our last valid index, well, we might not like that in a minute. So let's see. We might come back and change something about that. And then to pull off the shift, I could say, for example, like num's index I equals num's index I plus 1. Now, here's the catch, right? So if I did that, yes, that's going to take the value on the right and move it into the left index. So it's going to shift it left, like 85 would take over the 56. Here's the problem. If I go to the last index for I, which in this case would have been where that 100 is, there is no value to the right of that. And so this would end up going out of bounds. So I'm actually going to change this to say -2. I'm going to go to the second to last index, grab the last number and shift it over, but then I won't try to do it again. Now, there's something a little funny going on here if you didn't notice already. This is a voided return method. And if we look up above where I'm calling this, okay, I've created an array called values. I've handed values off to the method. Well, actually, I'm sorry, here I printed it. By the way, I'm using something from the arrays class, which you don't really need to know about, but it's just an easy way to print arrays. It puts the brackets and the commas and the spaces in. So anyway, I printed the array. That's where we see it originally. Then I handed it off to the method, and then I printed it again. So at this point right here is where the modifications to the array are supposed to happen. And what's interesting is this is that alias idea. When we hand away an array, it's an object. And so when it comes down here, it's actually getting aliased in this place called nums. So right here, when we see nums, that is now an alias to the values array from above. And so when we make changes to nums, we're simultaneously changing values because it's really the same array at that point. There's only one. It just happens to have a second name now. So again, that's that idea of objects passing their reference away, not values away. So it doesn't pass all these numbers. Like it never mentioned 56, 85. None of that is what actually passed from the method call to here. What passed was some weird memory address. If you wanted to see the memory address, you could actually print it. It's not going to mean much to you. But what I would do basically is like just like I did right here, but instead of using that nice arrays to string, which actually gives me the nice print, I would just print values, which is it's going to look a little funny to you because it's going to be a memory address, so it's not going to really mean anything to us. So if you ever print an array by name, you don't get this nice print. You get this. I don't know, what is that? Bracket I guess that stands for integer array at 2F2C9B. I don't know what that means. And you're not supposed to know what that means. Okay. But that's what a memory address or a reference looks like here. And so that's what's actually getting passed away through the method call, not those numbers. Those numbers don't get sent down there. It's the memory address. And so now nums has that memory address and it can refer to that same array where those numbers are stored. And if we make changes, then we're changing the values array as well. So anyway, let's see if our method worked. We see these numbers right here, 75 up through 28, 26, 25. Yeah, they're all showing up here. They've all shifted one left within the array. And then we're seeing the number 28, which was the last number, appear twice. And that's fine. That's what was supposed to happen in that case. So in the next one, we're going to do it a little differently. We're going to go to the right. Okay, so we'll probably have to change something here, may have to change something here. We're going to go 2 spots instead of 1. So +1 or -1 would now be like a +2, -2. And we're going to roll over. So like in this example, not only would I like to see these 84 and 89, replaced by the 59 and the 24, I'd like to see that 8499 actually jump over and take over the front of the array, because I can't shift them any farther to the right. So what I'll do is I'll roll them over to the front. The 84 would have become the 0 index, and the 99 would have become the 1 index as they moved over 2 spaces. Now, what I'm going to have to do is I'm going to have to actually use kind of like a swap technique to do this. So what I'll do is I'll make 2 variables. I'll make a nums0, and I'll put something there, and I'll make another one called nums1. And this is going to be operating kind of outside of the loop. So at the end of this whole thing, I'll just say num0, go ahead and put in there the one that I called num0, right? And at nums1, let's just go ahead and put in there nums1. I'm going to do that after the loop and all the shifting has taken place. Okay, so up here, well, which ones do I want? Well, like I said, the one that technically goes at the 0 index was the second to last value. So this would be nums found at nums length -2, not 1. And then I'm going to do almost the same thing right here, except this is going to be the one found at index 1. So those two are going to kind of operate outside the loop. Inside the loop, I'm going to be making changes to the rest of these. Now, again, if I went with my standard loop where I started it at 0 and walked all the way across the loop to nums length -1, I'm probably going to want to come back and change that. We can go ahead and leave it in right now, but let's just keep in mind that we might come back and change that. And to go right 2 indexes, like if this was nums I want it to come to me from nums. Let's see. So up above, I took one to the right and brought it left. Java always goes right to left, so we can't mess with that. So it might look a little peculiar to you here, but you'd actually write I-2, okay? Or another way that where it might make a little more visual sense for you is maybe to put I-2 here and put I here. And so that might look like a little bit more of like a shift to the right. Okay, I don't know what's going to work better for you, but like this is going to grab a number here. Well, actually, I'm sorry. I say one thing and I do another thing. So this is going to take a number and shift it to the right. So I'm going to take a number like 51, which is currently at index 2, and throw it into index 4. All right. And so that's going to be my shift right 2 indexes. Now, here's the problem. Okay, just like we saw in the last one, we can't go all the way across the loop making changes like this because this I+2 is not going to coordinate well with this guy. So I would have to change this to say -3. Or, we could try put it in the minus sign like I had it originally. Just whatever. Let's see what happens. All right, so notice that 73 through 24, 73, uh-oh. Let's try that again. You guys see what happened? So it turns out that if you're going to shift right, you have to actually loop backwards. So if you didn't catch it at first, what happened was I was putting those numbers in, but as I started going through the array, they were just picking up the numbers that I'd already shifted over. So the 7043 shifted, okay? But then what happened was now the 100's gone. The 27's gone. And so the 73 and the 43 just picked up again. And that would actually keep going on and on. So we got to be really careful. If we're going to shift right to left, we better actually totally reverse this loop and keep it in bounds. So what I think I'd like to do is actually start it at num's length minus 3, walk it back to 0, and go with a minus minus approach. Let's try that. Okay, so why do we start it at num's length minus 3? Well, the reason is let's say you got 10 numbers. The last index is 9. Okay, this would be 6. 6 plus 2. Well, yeah. Oh boy, now that's not going to work. So if I had 10 numbers, yeah, that looks good. So 10 minus 3 is 7, plus 2 is 9. So that actually takes me to the last index. All right, let's check it out. So here's 65 through 31. And now we actually see those numbers: 65, 59, 26, 33, all the way up to that 31. And then look at our 19 and our 28. All right, they moved right into the front. They rolled over. So that's perfect. It's tricky. If you want to shift the numbers to the right, you're probably going to have to write a backwards loop so that you don't overwrite them as you go. If you want to shift from right to left, then you want to go with a forwards loop. In the future, we're going to try to write a remove method. And this is going to be a real similar concept that's going to kind of plague us with that same idea. All right. And again, since I wanted the rollover, I had to hold on to these numbers. I couldn't try to do it through the loop process for the same reason as I had to reverse that loop. The numbers would have been lost in the interim, and I wouldn't have been able to retrieve them. So for like the exact same reason. And that kind of brings us to our last one here, the reverse numbers. Okay, so how would you reverse the elements of an array? Well, what you could do, because what you can't do, like what we just saw right here, you can't actually loop all the way across the array, because once you got halfway, you would have replaced some numbers, and then one of two things would happen. You'd either start to undo your changes, or if you didn't write your code well, it might actually start to just copy the same numbers again. But either way, it's going to be a little tricky. So what I'm actually going to do in this one is I'm going to set up a loop that only goes halfway across the array. And you could do either the front half or the back half, and it doesn't really matter. I'm going to start off with num's length divided by 2. And if I feel the need to change that, I'm going to come back and consider if I like that or not in a minute. But what I'm going to do at this point is I'm going to pull off a swap. Okay, so my swap is going to be num's I, and num's I needs to get replaced. And now this is where it gets a little tricky. I need to replace it with its counterpart at like the back of the array. Now, if I was at index 0, I would want the last number. So if this was a 0, okay, then this one would be the one at the back, num's length minus 1. Okay, they would be like counterparts. If this was a num's 1, okay, then I would go minus an additional 1, like move me 1 further in. If this was a num's 2, I would put another minus 2 here, like move 2 more indexes in. And so what ends up happening is we could actually just let I play that role. So with first up, when I is 0, you subtract 0, which doesn't do anything. You go to the last index. When I is 1, you back up 1 additional index. When I is 2, you back up 2, and so on. And then we can complete the swap by taking this number here and replacing it with the value that we are holding on to in the swap holder. That's going to do it. Now, if I have 10 indexes, half of 10 is 5, 0, 1, 2, 3, 4. Perfect. Okay, we go halfway across the array. Each step causes 2 numbers to swap. That's why we only want to go halfway. If you went all the way across the array, we'll try it. It would actually just undo your changes. It would be no good to you. If I had a length, let's say 9 array, half of 9 is 4, not 4.5 because it's integers. And 0, 1, 2, 3 would swap the first 4 indexes with the last 4, and it would leave the middle indexes alone, which actually doesn't matter because that's kind of like your pivot point. So I think this should do it. Let's go ahead and run and see if we get a reversal. And I intentionally gave you one even length array and one odd length array, and it should work for both. So see here, 3,566, and then down here I see 3,566. Going in 39, 92, 54. Yeah, looks good. And then it comes back across the other way. Here, the even length array, you can see like the 48 and the 3 in the middle. On the odd length array, you see 39 was in the middle. But here there's like a 2-number middle, so they swapped. And then you see them going out backwards from here, and everything looks good. If I didn't put that divide 2 there, what's actually going to happen is they're going to go across and swap everything. And then on the second half of the loop, it's going to actually undo all of your changes. And so you notice now, look at, I didn't go out of bounds or anything, but look, it didn't reverse anything. The changes I made on the first half of my iterations actually undid each other on the back half. So it's very crucial to stop this one halfway through. You could also start the loop at the middle index and then walk to the right of it. Now, I mean, it would have the same effect, but you only want to go halfway. So you got to be real careful when you start moving things around. If you're shifting left, shifting right, reversing, make sure you think carefully about that loop. Like I said, these loops, at least we didn't have to do a nested loop, but they were all still very tricky.